Bismillahirrahmanirrahim. Assalamu alaikum. In our last video, we have done exercise 1.2, question number 1 to 3. Now we will move to question number 4 to onward. For question number 4, we should know that what is the negative of any matrix. Negative of a matrix. Let A be a matrix then its negative minus A obtained by changing the sign of all entries of A. For example, if A is equals to 1, 2, 3 and 4, then minus A will be equals to minus 1, 3, 2 and 4. So it becomes minus A is equals to minus 1, 3, 2, minus 3, minus 2 and minus 4. Now what is the negative of a matrix? Negative of a matrix means if we take any matrix A, then we can get its negative, means minus A matrix, if we changing all the sign of all entries of A. It means that if the number is positive, then it becomes negative in negative matrix, and if the number is negative, then it becomes a positive in negative matrix. Okay, it means A is equal to 1, 2, 3 and 4, but minus A will be equals to minus 1, minus 3, minus 2 and minus 4. Now we will move to question number 4 of exercise number 1.2. Question number 4 is find the negative of matrix A, B, C, D and E when A is equals to 1, 0, minus 1, B is equals to 3, 2, minus 1 and 1. Now C is equals to 4, C is equals to 2, 3, 6 and 2. So if these are the matrices, now we will find its negative. So A is equal to 1, 0 and minus 1. It means that minus A will be equals to minus 1, 0 and 1. Minus 1 changes into 1 changes into minus 1, 0 changes into 0, because 0, positive 0 or negative 0 will be equals to 0, because 0 have no any charge, no any sign. 0 is non-negative but not a negative number, not a positive number, not a negative number. It is a non-negative and non-positive number. B is equals to 3, minus 1, 2 and 1. So minus B will be equals to minus 3, 1, minus 2 and 1, minus 1. means all the signs are changed into the negative of the matrices. Negative matrices means 3 becomes minus 3, minus 1 becomes 1, and 2 becomes minus 2, and 1 becomes minus 1 in the minus b. C becomes minus C when we changing all the sign. It means minus 2, minus 6, minus 3 and minus 2. All the signs are changed, so C becomes minus C. It means minus C is a negative of C. Now we will move to our next part. D is equals to minus 3, 2, minus 4 and 5, and E is equals to 1, 2, minus 5 and 3. So the negative of the D is minus D, and it becomes 3, minus 2, 4 and minus 5. It means all the signs of all entries are changed, so it becomes minus D. E, the negative of the E is minus E, which is equals to minus 1, 5, minus 2 and minus 3. All entries have different sign. All entries have the same entries but different signs in the negative matrices. Okay, so question number 3 is complete. Question number 4 is complete. Now we will move to question number 5. The question number 5 is find the transpose of each of the following matrices. First of all, what is the transpose? In our previous video, we learned that what is the transpose of a matrices. A transpose is a matrix which will be a transpose of a matrix is find by the changing rows into columns and columns into the rows. For example, if we have any matrix A 1, 2, 3 and 4, then A transpose will be equals to 1, 2, 3, 4 transpose, which will be equals to 1, 2, 3 and 4. So it becomes the transpose. Okay, now we will move to question number 5, first part. Part 1 is A is equals to 0, 1 and minus 2. B is equals to 5, 1, minus 6. And C is equals to 1, 2 and 3, 2, minus 1 and 0. Okay, so A transpose will be equals to 0, 1, minus 2 transpose, which will be equals to 0, 1, minus 2. The next is B. So B transpose is equals to 5, 1, minus 6 transpose, which will be equals to 5, 1, minus 6. C is equals to C transpose will be equals to 1, 2, 3, 2 minus 1, 0 transpose, which will be equals to 1, 2, 3, 2 minus 1 and 0. If you notice that, you can easily understand it that if a matrix is a column matrix, then its transpose will be a row matrix, and if we take a matrix, any matrix which is a row matrix, then its transpose will be a column matrix. Okay, it means that the number of rows changes into the number of columns, and the number of columns changing into the number of rows. The next is D is equals to 2, 0, 3 and 5. E is equals to 2, 3 minus 4 and 5, and F is equals to 1, 2, 3 and 4. Okay, now if D is this, then D transpose will be equals to 2, 3, 0 and 5. Transpose is equals to 2, 3, 0 and 5. So E transpose will be equals to 2 minus 4, 3 and 5 transpose, implies that its transpose will be equals to 2, 3 minus 4 and 5. So F transpose will be equals to 1, 2, 3 and 4 transpose equals to 1, 2, 3 and 4. So we can easily solve our question number 4, which is the transpose of every matrices, and we find each matrix, each transpose by using this trick that we should change the rows into columns and columns into the rows. Now we will move to the question number 5. Question number 6. Question number 6 is the last question of the exercise. Question number 6. Question number 6 is that verify that if A is equals to 1, 0, 2 and 1, and B is equals to 1, 2, 1 and 0, then A transpose whole transpose is equals to A, and B transpose is equals to B. So we first solve A transpose is equals to A. The transpose of A transpose will be equals to A is obvious, but we should solve it for the verification. Okay, so first we solve this, so we can remove this. Okay, we take left hand side is equal to A transpose is equals to the transpose of A transpose will be equals to A. Okay, for this purpose we should solve first the bracket. So we take A transpose will be equals to 1, 0, 2 and 1 whole transpose is equals to 1, 2, 0 and 1. Now we move to the other side. Now A transpose whole transpose, we find the transpose of A transpose, that is equals to the 1, 2, 0, 1 transpose, which is equals to the 1, 0, 2 and 1, and here is the transpose of A transpose. So we can easily see that this is again A, so we can say the transpose of A transpose will be equals to A. So left hand side is equals to right hand side. Okay. This is the most simple question. What is the question? That verify that if A is equal to 1, 2, 0 and 1, then the transpose of A transpose will be equal to the A. It means that we should solve it by step by step. Okay. In first step we take left hand side. By taking left hand side, the left hand side was the transpose of A transpose, and to solve this we should take only the bracket side. Okay. We should take only that part which is in the bracket. So we take A transpose. First we find A transpose. What is the A? A is that 1, 2, 0 and 1, and we take transpose of this matrix. It becomes 1, 2, 0 and 1. Okay, this is the A transpose. Now we will find the transpose of A transpose. So for this purpose we take A transpose, that is the 1, 0, 2 and 1, and then we take its transpose both sides. When we take both side transpose, it becomes 1, 0, 2 and 1. So the transpose of A transpose will be equals to A. So left hand side is equals to right hand side, which we want to prove. Now we will move to B part. B part is that B transpose. The transpose of B transpose is equals to B. So first we take left hand side. Left hand side is the transpose of B transpose, and for this purpose we take only the term that is in the bracket. So it is the B transpose. First we find B transpose, and the B transpose will be equals to 1, 2, 1 and 0 transpose, which is equals to 1, 1, 2 1, 0. So now we find the transpose of B transpose, which is equals to 1, 1, 2 and 0 transpose, which is equals to 1, 2, 1 and 0, and the left hand side is the transpose of B transpose, which is the transpose of B transpose is equals to B, because B is equals to 1, 1, 2 and 0, so it is equals to B, which is that we want to prove. So we can say that left hand side is equals to right hand side proved. Now we should understand all the terms one by one. So all the exercise is complete. Now we start exercise number 1.3 in our next video.